Let's go ahead and look at example 2. This time we are asked to find the zeros and graph. Remember that finding zeros is the same as what we did before. Roots, zeros, x-intercepts, and solutions are the same thing. So just like before, we will start off by seeing if we have a greatest common factor. And this time I see that x is my greatest common factor. So I will write an x out in front and then rewrite what I have left after that, which is going to be x squared plus x and minus 6. And remember, we're going to set this equal to 0. So f of x has been set equal to 0 because that's how we solve. Let's go ahead and label that we just did a greatest common factor. Next, we want to look at how many terms we have left. 1, 2, 3 in parentheses. And so what 3 terms leads us to using is an X box. This is quadratic form, so we are going to do an X box next. Let's fill out an X box. You should be an expert at X boxes by now. So a times c, 1 times negative 6 is negative 6, and I need factors that add to 1. So for negative 6, to add to a positive 1, I need my smaller factor to be negative. So negative 1 and 6, negative 2 and 3, and the 2 factors that are going to solve my X puzzle is negative 2 and positive 3. So let's go ahead and write those, negative 2 and 3. Those will also show up as a 3x and a negative 2x in my box part, and I fill in with my first and last terms. So x squared and minus 6. And now I'm ready to do a greatest common factor. Between x squared and 3x, my top row, I have an x. And then for my bottom row, a negative 2x and a negative 6 will be a negative 2. Remember the very important rule that if we have a negative in the box we're about to write, next to the negative comes along. X squared and negative 2x is an x, and then 3x and negative 6 is a 3. So I can write my further factored polynomial as x times x plus 3 and x minus 2, and this is still equal to 0 now that I've done my x box. Now I need to see if I can factor any more. Well, this is a monomial factor. We talked about monomial factors being done. We can't factor them anymore. These two are both linear because I just have a plain x, not an x to any power other than a 1. So I am done with factoring, and now I just want to solve. So in order to solve, we use zero product property just like we did above, and I'm going to set each of these pieces equal to 0. I have 3 different factors. So x is equal to 0 from that first factor, x plus 3 equals 0, or x minus 2 equals 0. Well, x equals 0, that's already solved for me. I don't need to do anything else to that. I can subtract 3 from both sides here to get x is equal to negative 3, and then finally add 2 to both sides to get x is equal to 2. And those are my solutions, or my zeros, roots, x-intercepts. Speaking of x-intercepts, we will go ahead and draw these as places where we cross the x-axis. So I have a point at negative 3, at 0, and at 2. Other things that I want to identify in order to properly graph is I want to know which direction my polynomial is going. And in order to do that, I need to bring in my skills from previous lesson to identify my degree as 3, which is odd. Remember, for degree, we care odd or even. For lead coefficient, we care about positive or negative. I have the implied 1 here in front of the x to the third, and so I will say my lead coefficient is 1, and that's positive. So I can draw my arrows. Lead coefficient positive means the arrow on the right is positive. Odd means opposite. Remember, both of those start with O, so the one on the left goes down. The other thing I want to know is my y-intercept. And actually, I already have it because there happens to be a 0 there. So the origin at 0, 0 is my y-intercept. However, the way that we would normally find our y-intercept being 0 is that we would look for a constant here. I end with a negative 6x. I have no constant, so that means my constant is 0. So let's make ourselves a note about that. Let's say that this is the constant in the original f of x. Not always going to be not there. Sometimes we'll actually have a number, and that will be our y-intercept. All right, so let's take this information and graph. I know that my graph is going down on the left, so I'm going to draw an arrow generally going down and to the left. It's going up as we go to the right, and I just need to fill in between with nice smooth curve that hits all of those points.